All right, so the first day of our Unit 1 notes, we're going to be talking about trigonometric ratios, okay? So I just want you to recall, okay? And you should remember this from geometry, right? SOHCAHTOA, sine, opposite, SOHCAHTOA. Right? So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, okay? So in this whole unit, we're going to be looking at solving right triangles, okay? We will get to a unit in Unit 3 where we will solve non-right triangles, right? So things to recall, okay? The biggest thing when dealing with a right triangle is that we know that all triangles add up to 180 degrees. When you say you have a right triangle, that means that one of the angles is always 90 degrees, okay? So when you're looking at this document here, okay, if we're looking at angle A, okay, the first thing we always need to do is we need to determine what is our opposite, what's our adjacent side, what is our hypotenuse. So if I'm looking at angle A right here, opposite is going to be down here, okay, adjacent here. Now, the first thing that you always do is that you always label your hypotenuse, okay? Your hypotenuse is always going to be the longest side, okay? And it's always going to be opposite the right angle, opposite the right angle here, okay? And so that's how we determine that. Now, if we're looking at angle B though, okay, angle B, now, here's my opposite side, here's my adjacent side, okay? The hypotenuse never changes. The hypotenuse never changes, okay? So therefore, that's the biggest thing you have to remember how to do. If you know how to do that, then it will be a lot easier for when we start talking about sine, cosine, tangent, solving those right now. So fast forward this to when I get to the next part of trigonometric ratios. All right, so trigonometric ratios, right? Trigonometric ratios. What are those? That's sine, cosine, and tangent, right? Sine is the ratio of the lengths of the side opposite and the hypotenuse. Hence, in SOHCAHTOA, sine opposite over hypotenuse, okay? Cosine, or cosine theta. Now, guys, theta is just another, it's just another symbol for angle, okay? It's a Greek symbol here, theta. You'll see me use that a lot when we're trying to solve for angles on next Tuesday, okay? So cosine theta is the ratio of the lengths of the adjacent side to theta and the hypotenuse. So hence cosine adjacent over hypotenuse, okay? And then tangent is, or tan theta is the ratio of the lengths of the sides opposite theta and adjacent to theta. So think TOA, tangent is equal to opposite over adjacent. Okay? So give me another 20-30 seconds here and we will get started on these two example problems. Okay, so both of these problems want me to use SOHCAHTOA to find the values of sine, cosine, and tangent, okay? So I've got 5 and 12 here, but I do not know this side, okay? I do not know this side. So the first thing I need to do is I need to find that missing side. Well, since this is a right triangle, guys, I can use Pythagorean theorem. I can go a squared plus b squared equals c squared. So let's go ahead and let's set that up. Now, c squared is always going to be your hypotenuse. It's your largest side, okay? All right? So when we're doing this problem here, we're going to get this. We're going to get 5 squared plus 12 squared equals c squared, okay? Equals c squared, all right? And let's go ahead now and simplify it. So 5 squared is 25. 12 squared is 144. equals c squared. That now gives me 169 equals c squared. And to now solve for c, I'm going to go ahead and square root both sides, and that's going to give me 13 equals c. Okay, so we know 13 is our longest length, our hypotenuse. Now, it wants me to find sine, cosine, and tangent for angle A. So angle A is right here. Okay, angle A is right here. So the first thing I'm going to do is I'm going to label my opposite and my adjacent side. I already know this is my hypotenuse. Why? Because this is my right angle. Opposite my right angle is always the hypotenuse. Every time. It's always your longest side as well. Okay? So, based on angle A here, that means this has to be my opposite side, and then this has to be my adjacent side. Okay? So how we label that is this. We are trying to find sine of angle A. Okay? And so, what is sine equal to? Sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So let's go ahead and let's say, well, what's my opposite side? It's 12. My hypotenuse side is 13, and there you go. That's your ratio. That's your sine ratio for this given triangle. Okay? All right, let's talk cosine then. So now cosine of angle A. Remember, cosine is equal to adjacent over hypotenuse. So what is my adjacent side? My adjacent side based on angle A here is 5. And we know my hypotenuse is 13, so therefore my trig ratio for cosine in this problem is 5 over 13. Okay? And then last but not least, tangent. Okay, tangent. So tangent of angle A, okay, what is tangent equal? It's equal to opposite over adjacent. So what's my opposite side here? 12. And then my adjacent side is 5. So therefore, my trig ratio for tangent then is 12 over 5. Okay? So give you a second look at that before I scroll up for the next problem. All right, now angle A for this second problem here. Okay, again, first thing I always do is angle A. There's angle A. All right, so I need to label all my sides first. Here's my right angle. Okay, so I know then that this is my hypotenuse every time. Okay, so based on angle A, then this is going to be my opposite side, and this is going to be my adjacent side. Okay? So then my next step is to go ahead and find the missing side. Okay, so again, Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Okay, so this time I'm going to get 8 squared plus b squared equals 17 squared. Guys, the hypotenuse always has to be part of c. That's the only requirement. The only requirement, okay? If I was to put 17 for b, that would totally mess this problem up. Okay, so let's go ahead and continue with what we know. So we know that this is 64 plus b squared equals 289. All right, so go ahead and solve for it. So then when you subtract the 64, you're now left with b squared equals 225. And now what I'm going to do is I'm going to square root both sides. I mean, not 15, sorry. Not 25. 15. So once we have our three sides, now we can come up with our sine, cosine, and tangent. We just have to remember SOHCAHTOA. So I have to remember SOHCAHTOA. So again, sine of angle A, opposite over hypotenuse. Okay, so what is my opposite side from angle A? 8. What's my hypotenuse side? 17, and there you go. So that's your ratio for sine of angle A. Sine of angle A. Okay, let's look for cosine of angle A. Again, what is cosine equal to? Adjacent over hypotenuse. And so then what is that going to give you then? What is my adjacent side based on angle A? 15. And then my hypotenuse is 17, so your ratio is going to be 15 over 17. And then last but not least, tangent. Okay, opposite over adjacent. So opposite, 8 over adjacent, 15. And there you go. There's your ratios for sine, cosine, and tangent. Now, there are a lot of what we call popular Pythagorean triples. Okay, excuse me. Those are 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. So just memorize those. It makes it easier to where maybe then you do not have to find the missing side length. Okay. Now, can't guarantee it's always going to be like that. I do like to use those. Okay, with the beginning content. Okay. All right. So now I'm going to scroll up. We're going to extend on now from topics from geometry. We're going to learn the reciprocal values of sine, cosine, and tangent, the reciprocal ratios. Okay. All right. So when you did geometry a couple of years ago, they only talked about sine, cosine, and tangent because at that time that was all you needed to know to excel that year in class, right? To understand. Now, with anything in math, to undo something, you have to have a reciprocal, right? So if I have something like this, right, where I have 2x equals 8, well, that's 2 times x. Well, how do I undo that to solve for x? Well, what's the opposite of multiplication? Division, right? And so the same thing happens in trigonometry, okay? And so sine, cosine, and tangent have reciprocals as well to help you, and you'll see when we get to solving these late in this semester why it's so important. Okay, so the reciprocal for sine is cosecant, okay? And all you do with reciprocals, when we do reciprocals, we just flip, right? So the ratio for cosecant then is hypotenuse over opposite, okay? The reciprocal for cosine is secant. Secant, we just, to get that, we just flip cosine. So secant is now equal to hypotenuse over adjacent, okay? And then last but not least, cotangent, okay, or COT, theta there, is the reciprocal of tangent. So if tangent was opposite over adjacent, then cotangent is going to be adjacent over opposite. Okay? So let's go ahead and let's solve a problem finding all 6 of our trig ratios. All right, so I've already drawn the triangle for you, okay? If cosine of theta is equal to 2 over 5, find the exact values of the 5 remaining trigonometric ratios for theta, okay? So I already drew the triangle for you guys, okay? And I found all the sides. So we've got 2, square root of 21, and we've got 5. So the first thing is that we're looking from this angle down here of theta, okay? So I need to define everything. I know then that this is my hypotenuse, opposite the right angle, okay? Longest side on the triangle, okay? Based on theta here, I know then that this has to be my opposite, and then that this is my adjacent, okay? Opposite, adjacent, okay? So let's go ahead now and let's find all of our ratios, okay? So we know sine of theta is equal to opposite, again, over hypotenuse. Okay, so my opposite is square root of 21. My hypotenuse is 5. Okay? And so then there you go. So there's sine of theta. Okay? Cosine of theta, we know cosine is equal to adjacent over hypotenuse. And so what is adjacent? 2. Hypotenuse is 5. And therefore then my ratio for cosine then is 2/5. Okay? Tangent of theta we know is opposite over adjacent. So my opposite side, square root of 21, adjacent side, 2. Okay? All right, so that's our original 3. So now we need to add on though. Cosecant, secant, and cotangent. So, oh wow, sorry about that. Dead marker. So cosecant of theta now is hypotenuse over opposite. And so what that means is that then I'm just taking sine. Once I find sine, guys, I'm flipping it. Now, if you have a TI-36X, the one I talked about on last Monday, okay? If you have that, you can just type it in as 5 over square root of 21 and it'll simplify it for you. If not, you have to remember how to rationalize the denominator. And the reason why is because we cannot have a square root in the denominator. So what I'm doing is I'm taking the denominator and I'm multiplying it by top and bottom. And so by doing that, now in the numerator I've got 5 times the square root of 21 over just 21 now. When you take a radical expression like this and you multiply it by itself, when you do that, you're getting rid of the square root sign. So then our final answer then for cosecant of theta would be 5 times the square root of 21 over 21. Okay? Let's go secant now, which is the reciprocal of cosine. So since the reciprocal of cosine, that's now going to be hypotenuse over adjacent. And so when we do that, we're just taking our cosine of theta here and we're flipping it. And so that now gives you 5 over 2. Now this time I don't have to do anything to it because I don't have a square root in the denominator. So therefore that's easy and I'm done. All right, last but not least, cotangent of theta, which is the reciprocal of tangent. Okay, reciprocal of tangent. And so that means then it's going to be adjacent over opposite. So then all I'm going to do then is I'm going to flip tangent. And so I'm going to get 2 now over the square root of 21. Again, we've got a square root of 21 in the denominator there, so that is a problem. So again, if you have a TI-36X, go ahead and type in 2 over square root of 21, enter, it'll fix it for you. If not, you have to rationalize. So I'm going to multiply top and bottom by the square root of 21. And so when I do that, I'm going to get now 2 times the square root of 21 over 21. So guys, that's it. The biggest thing we understood today is that we learned about cosecant, secant, and cotangent, the reciprocals of sine, cosine, and tangent, and how to find those ratios. Okay? If you have any questions, please go ahead and we will ask these during our live session. I highly recommend starting now going ahead, that if you get the opportunity, you watch these videos ahead of time. Okay? With that though, thank you guys, and I will see you in class. Bye.